Hi everyone, my name is Chandana. I'm from Sri Venkateshwara College of Engineering. Currently, I'm pursuing my graduation in 7th Sim ECE. So, today's subject is Automotive Electronics. So, topic of my subject is Electronic Control System and its performances. So, contents of my topic is Introduction to Engine Control System, Functions of Engine Control System, Applications of Engine Control System, Advantages of Engine Control System, and Disadvantages of Engine Control System. Firstly, we will be move on to the introduction and functions of engine control system. Engine control system allows the engine to perform at maximum efficiency for a given condition, aids the pilot control and monitor the operations of the aircraft power plant. So originally engine control system consisted of simple mechanical linkages controlled by the pilot, then evolved and became the responsibility of the third pilot, certified crew member, the flight engineer. So by moving levelers directly connected to the engine, the pilot or the flight engineer could control fuel flow, power output, and many other engine parameters. So, following mechanical means of engine control came to introduce of analog electron engine control. Analog electronic control varies and electrical signals to the communicate the desired engine settings. It had its own drawbacks, including common electronic noise interference and reliability issues. Next is functions of engine control system. So FADEC works by receiving multiple input variables of the current flight condition, including air density, total level position, engine temperature, engine pressures, and many other parameters. The inputs are received by EEC and analyzed up to 70 times per second. So engine operating parameters such as fuel, starter vane position, bleeding valve position, and other are computed from this data applied as appropriate. It controls engine starting and restarting. Its basic purpose to provide optimum engine efficiency for a given flight condition. It also allows the manufacturer to program engine limitations and receive engine healthy and maintain report. For example, it avoids exceeding a certain engine temperature. The FADEC can be programmed to automatically take a necessary measure without pilot intervention. So the flight crew first enter the flight data such as wind condition, runway length, or cruise altitude into the flight management system, that is called FMS. The FMS used this data calculate power setting for the different phases of the flight. At takeoff, the flight crew advances the throttle to a predominant settings or opts of a auto throttle takeoff if available. So next is applications of engine control systems. So actually engine control systems are applied in FADECs are employed by almost all current generation jet engines and increasingly in piston engines for fixed wing aircraft and helicopters. So the system replaced both magnetons in piston engine aircraft, which makes costly magneton maintenance absolute and eliminates carburetor heat, mixture control, and engine priming. Since it controls each engine cylinder the dependently from optimum fuel ingestion and spark timing, the pilot no longer need to monitor fuel mixture. So advantages of engine control system is it is better fuel efficiency, automatic engine protection against out of the tolerance operations, and it is safer as the multiple channel FADEC computer provides redundancy in case of failure, carefree engine handling with granted trust settings, ability to use single engine type for wide thrust requirements by just reprogramming the FADECS. So provides semi-automatic engine starting. So it is better system integration with engine and aircraft system. So disadvantages of EDC are: it is no form of manual override available, placing fuel authority over the operating parameters of the engine in the hands of the computer. If the total FADEC failure occurs, the engine will fail. So, in the event of a total FADEC failure, pilots have no way of manually controlling the engines for a restart or to otherwise control the engine. With a single point of failure, the risk can be mitigated with redundant FADECs. So that's all about my topic. So thank you all.